Hello everyone. So this is a question from NEET 2026. In a qualitative analysis, bismuth plus 3 is detected by appearance of precipitate of BiOOH solid. Calculate pH when the following equilibrium exists at 298 Kelvin. Okay. So this is the equilibrium. We have to calculate the pH of the solution when this equilibrium exists. BiOOH solid, BiO plus aqueous plus OH minus aqueous. The equilibrium constant is 4 into 10 power minus 10. Log 2 is 0.301. The chapters involved is equilibrium. Okay, so BiOOH is like a sparingly soluble salt. A sparingly soluble salt is, a salt which is very, very less soluble in water. Okay, so BiOOH is like a sparingly soluble salt. So when it is stirred or mixed with water, whenever we, let's say we have a beaker and we have some amount of water, and when we add this guy into a beaker and then we, stir or mix it with water, only a small amount of it goes into the solution because it is sparingly soluble. So very small amount goes into the solution or in water to form a solution. But whatever little amount of salt dissolves, whatever little amount that dissolves in water, it gets completely dissociated into ions. Okay, therefore the equilibrium can be represented by a reversible reaction. I can show it to you. So obviously it's a sparingly soluble salt, so only small amount of it goes into the solution, but whatever little amount of salt dissolves, it gets completely dissociated into ions. So in terms of reactions, we can show it like this: BiOOH solid, BiOOH aqueous. Okay, so this is, the undissociated or the left salt because it is sparingly soluble. So obviously small amount will be soluble in water and rest will be undissociated or left. So this is the left amount of the solid salt, and this is whatever amount of salt that went in the solution, that went in the water to form a solution. So these two are will be in equilibrium. Okay, and whatever went in, that is this guy, whatever went in will completely dissociate into ions. So we can further show it in this fashion, that it dissociated into the respective ions. Okay, so this is undissociated, or the left amount of the salt. This is whatever went in and dissolved, and this shows whatever went in, it got completely dissociated into ions. Okay, or we can, directly write BiOOH solid is in equilibrium with BiO plus aqueous, the ions, plus OH minus aqueous. Okay, and now applying law of chemical equilibrium, we have K is equal to the concentration of products raised to their stoichiometric coefficient divided by the concentration of reactants raised to their stoichiometric coefficient. So we'll be having BiO plus aqueous raised to the power 1 because the stoichiometric coefficient is 1 for both of them. OH minus aqueous raised to the power 1 divided by concentration of BiO OH solid raised to the power 1. Okay, since the concentration of undissociated or the left solid, that is this guy, it remains constant, therefore we can write K is equal to BiO plus aqueous into OH minus aqueous, and K is given to us as 4 into 10 to the power minus 10. So let's say this is equation 1, very important. Okay, from the stoichiometry, That is from this reaction, that is BiOOH aqueous, giving us BiO plus aqueous, the respective ions, plus OH minus aqueous. Okay, so this is, whatever amount went into the water, whatever dissolved into the water, and these are the ions that it furnished in water. Okay, so we can see the concentration of BiO plus, concentration of these ions in the solution will be equal to the concentration of the salt, whatever dissolved in water. Similarly, because their stoichiometric coefficient is 1, similarly, the concentration of OH minus furnished in the solution will be equal to the concentration of salt dissolved in water, right? So therefore, I can write concentration of BiO plus aqueous will be equal to concentration of BiO OH aqueous, and concentration of OH minus aqueous will be equal to concentration of BiO OH aqueous. So this is also because their stoichiometric coefficient is 1. So this guy dissociates to give one molecule of this guy give you one BiO plus ion. One molecule of BiOOH gives you one OH minus ion. So therefore their concentrations will be respectively equal to BiOOH and BiOOH. Okay. So therefore we can say that concentration of BiO plus aqueous will be equal to concentration of OH minus aqueous, because both of them are respectively equal to BiOOH. So therefore these two concentrations will be equal. Okay, cool. So therefore, using this in equation 1, our equation 1 was this. Okay, so BiO plus concentration and OH minus concentration are equal. So therefore I can write OH minus concentration whole square is equal to 4 into 10 to the power minus 10. Therefore, the OH minus concentration will be equal to square root of 4 into 10 to the power minus 10. And I can write square root of 4 into 10 power minus 10 as, I can write 4 as 2 square, and I can write 10 to the power minus 10 as 10 to the power minus 5 whole square. So therefore square root of 2 square into 10 power minus 5 whole square will be equal to 2 into 10 to the power minus 5. So this is the concentration of OH minus, 2 into 10 power minus 5 molar. Okay. Therefore, from the concentration of OH minus, I can calculate POH. POH, we know it is equal to minus log of OH minus concentration. We know the OH minus concentration. So POH will be equal to minus log of 2 into 10 to the power minus 5. Right? So to solve this, we should know that log of A into B is equal to log of A plus log of B. Okay, very important. So therefore, using this identity, I can write I can write this as minus of log of, obviously, base 10 2 plus log of base 10 10 to the power minus 5, right? And log 2 is given to us as 0.301. And to solve this guy, we have to know one thing, that log of 10, let's say log of A, base A to the power m is equal to m. Okay, this is important. So you can see here it is log of 10 to the power minus 5. So the answer will be plus minus 5. Okay, because of this identity. So therefore, I will have minus of 0.301 minus 5. So therefore, ultimately you will get it as 4.699. Okay, so therefore, the POH is equal to 4.699. In the question, they have asked pH. Okay, we know that the relation between pH and POH is pH plus POH is equal to 14, right? And pH therefore will be equal to 14 minus POH. So therefore pH will be equal to 14 minus 4.699. So therefore pH is going to be 9.30 So therefore, the pH of the solution is 9.301. Okay. Thank you.